Hi, welcome back to ZW3D Design Tutorials. This is Ben. In this lesson, you will learn how to define 2D sheet templates, new 2D sheets, sheet manager function, how to create view layouts, add dimension, and 2D tables. Let's get started. First, 2D sheet template. Two key points will be introduced: how to customize the new template and how to link with the part attribute in 2D sheets. Now open ZW3D. Open configuration to see template setting. File table. Template file is template_mm.z3. Click No. Open the template file. Several different size and standard templates are provided, but we need to create a new drawing sheet. Name it A3_H. ZWSoft. This is an empty template. Step 1. Edit sheet format. In this dialog, you can use standard template or customize it. Select the needed size from the list. Customize the configuration. For example, pick all these options, including border, bound, trimming mark, partition, center mark. Then define block type. Click OK to finish. Take a look at this title block. Next, I will show you how to create a link relation with part attribute. Expand sub-items of sheet format. Edit title block. Enter sketch environment. There are some default relations, such as sheet size, sheet scale. Now, create some new one by text command. Define text position. Input text by editor. Open the variable browser. Pick needed part attribute, such as part name. Click OK. The relation expression is created. Continue to add others, such as part designer. Then part manager. Add a material relation. Input text by editor. Type material. Add variable. Finish. Change text attribute. Use copy command to quickly get the needed attribute from other objects. Exit sketch. This template customization is finished. The new one is included in template files. See? Second, new 2D sheets. Except for creating new file, in ZW3D modeling environment, we can directly open 2D sheets. It is very convenient. Third, Sheet Manager. It integrates sheet management, sheet format definition, table functions, and view information. View layout. ZW3D provides standard view, projection view, section view, detail view, and so on. The following section will introduce how to create these views and how to edit section view. Look at a shaft case. Open the file. This is a shaft model. Firstly, take a look at the part attributes, including part name, designer, manager, material. Okay, close the window. Right-click to create a new 2D sheet. Select a template. Use the customized template we built. Create a standard view. Select front view and turn off the hidden lines. Look at the title block firstly. Linked part attributes is displayed here, including material, designer, manager, parts name. Look at Sheets Manager. Sheets information includes sheets format, table function, and views. Model information is listed in each view. Multi-sheets is supported. Right-click to insert a new one. Also, there is another quick method. Click this plus icon to create a new one. Now, insert a view layout. Change projection method. Finish. When you put your mouse over the sheet's name, the sheet's preview is displayed. Click it to activate. In Sheets Manager, each view item includes model information. Now continue to create views. Add broken section view on this front view. Pick view. Define the boundary and depth point. Unpick dynamic hatch. Get this broken view with key groove information. Create another one on the other side. Same operations. Pick views. Define the boundary and depth point. This side includes key groove and hole features. Next, create section view. Pick base view and direction points. Set location method as none. And define the location point. Finish. This is the section view, but I want a cross-section view. How to do it? Redefine it. Set section method as sec curves. Now, this is the cross-section view. Create another one. Pick base view, direction points, and location point. Done. Let's modify label attribute. Label tab. Don't show label prefix. Change height value. This is the result. We do it again. To keep a uniform position, the label bin needs to be moved. Set filter as text firstly, and then move the label. All views for this shaft case have been created. The next section is dimension. we will introduce how to create proper dimension and tolerance, how to define or change the dimension attribute, add annotation and symbol, and some skills. First, take a look at Style Manager. In this manager, we can define dimension standards and detail style. So, how to customize it? I'll show you the steps. Step 1. Define the style attribute. For example, linear style. You can choose to change some parameters, like position, text position, click the Text tab, and you can change the text shape value. Then click Save As, give it a name, add ZWSoft as the postfix. Change chamfer style, define precision type, and modify text shape. These values are the same as before. And save as the new style. Step 2. Select the needed styles. And then save as a new standard. Activate it. Now, add dimension for these views. First, use Quick Dimension command. Pick the points to create length dimension. First section is 49. Second one is 110. Third one is overall length, 394. For the other side, the first one is 40. And second one is 130. Add dimension for broken section views. This one is 9.4. Add the diameter symbol. Then it comes to the other side. Repeat the operations we just did. Use another method to add the diameter symbol. Here, you can add some special characters. Right-click on Ribbon bar. Select Toolbars and find Dim Tools to bring up the Quick Dimension tools. Apply it. It is very convenient. Create others. The middle part is diameter 70. The fourth section is diameter 65. The smaller one is diameter 55. Now, add dimensions for these cross-section views. Section A, the width of key groove is 14. This height distance is 60. Section B, width is the same, 14. Height distance is 50. Add the tolerance for it. Set the tolerance type and zero tolerance display type. Upper tolerance is 1. The lower is 0.2. Modify this one. Just copy attribute from other objects. Then, hide quick dimension toolbar. Next, add some chamfer dimension. Click chamfer, select chamfer line and define position. The chamfer is 2x 45 degree. For the other side, chamfer dimension is the same. We can use a new text format. C1 and show prefix, then it will be displayed as C2. Except these different dimensions, we will add some annotation such as label, feature control, symbol, datum and so on. First, add a label for the whole feature. Define the locations. Input the text in the editor. Insert the needed symbol and input the whole parameters, including diameter value and depth value. This is a counter bore. Now finish. You can also modify the text attribute. For example, height is 2.5, width is 0.75, and gap is 0.2. This is the final result. Second, create a datum symbol. Define the datum name, select the target entity, and define the text position. Change into another display type to finish. Next, add a feature control symbol. In this editor, select the needed symbol, concentricity, define the tolerance, diameter 0.06, and add datum A. Click OK. Define the location points. This is the example for feature control symbol. Next, add center mark for those cross-section views. Select the arc and suitable type. Create another one. Add center line for the front view. Pick two lines. Modify the extension length value. and use another line width type. Finish. Last, add service finish symbol for these views. Define the location point, adjust the orientation to get the needed one. Select the symbol type and input the value information. This one is 1.6. Create others. Second one is located on shoulder surface, and the value is 3.2. Third one is on the middle part. Repeat the operations and the value is 12.5. Add them on cross-section views. For side surface, this value is 3.2. For bottom surface of key groove is 6.5. For the other one, the requirements are the same, so just repeat the operations and type in the value. Last thing is adding some technical requirements. Choose tab drawing and click text. Define the location point, and then input the text information according to the real demands. For example, you can write a technical requirement here. So far, these 2D sheets is finished. You can save it. Last section is 2D table. We will introduce how to create tables, such as BOM table, how to edit tables, such as modify balloon location, synchronize BOM table with part attribute, and how to import and export the table. This is a reducer assembly drawing. It includes 3 different views. In Sheet Manager, each view contains assembly information. To more clearly see the internal structure, hide the cover component on top view. Next, create a BOM table. Select the view and enter a name for the table. Add material, designer item. Remove cost and number item. Click OK. Item balloons are generated, and insert table command is automatically activated. Just need to define the location point. Next, let's edit the balloons in the new order and modify balloon locations. Drag and drop any balloon to the new location. Change the arrow position of balloon 6 by modify table balloon command. Double-click to modify balloon text. Change 6 into 4. Continue to adjust others. Change 10 into 8. Relocate the last one and change it into 10. Finish. It is more clear now. Take a look at this table. It needs to be modified and put items in order. Right-click, Edit Table. Define the needed sort. OK, BOM table is updated. Now, back to the modeling environment. Let's check some part attribute information. This is a big key part. On part attribute table, there is no description information. Return to assembly and go into 2D Sheets. Edit the table. Click Open Editor. Here, we can edit or add these attributes. For example, add description for big key part. Do it again. Add description for small key part. Click OK and finish it. See, the table is updated. Next, let's synchronize the BOM table with part attribute. Right-click, choose the synchronization command. Return to the modeling environment to check part attribute. This is the big key part. The description information is added. Let's see the small key part. The attribute is also updated. Same with 2D Sheets information. Go back to 2D Sheets again. Last, let's see how to export and import table. Right-click the table, select the export function, save as the Excel file. Then, check it. Open this Excel file. We could edit it by Excel function. For example, add some description. Save it. To confirm the import table function, I create a new sheet. Right-click Import Table and select that Excel file. In this table editor, we can edit it again if needed. Insert table. Check it. So these are all the functions about 2D sheets.